Chapter 2, Section 2, Two-Step Equations. Now we're going to use the additive inverse and the multiplicative inverse to solve two-step equations. One thing that I want to make sure that people understand at this point, when you do a two-step equation, you do all the additive inverses first, and then you go to the multiplicative inverses. Let me show you what I mean. Let's take an equation. 5x minus 3 equals 12. If you take a look at this equation, we have an additive inverse and we have a multiplicative inverse we have to do for this equation. This is a two-step equation. First, we're going to do the additive inverse. So we take a look at this and we say, what is the additive inverse of a negative 3? Well, we know the additive inverse of a negative 3 is plus 3. And remember, whatever we do on one side of the equation, we have to do on the other side of the equation. In other words, whatever we do on this side of the equal sign, we have to do on this side of the equal sign. So if we added 3 here, we have to add 3 here also. All right, remember on our additive inverses, we can put a line underneath them. We carry our 5x down. Minus 3 plus 3 is 0, so we really don't have to write anything there. We put our equal sign in, and then 12 plus 3 is 15. Now we're left with an equation of 5x equals 15. Now we can do our multiplicative inverse. What is the multiplicative inverse of 5? Well, we know that the multiplicative inverse of 5 is 1/5. So we can multiply this side by 1/5. If we multiply this side of the equal sign by 1/5, then we have to multiply this side of the equal sign by 1/5. Now we can solve the equation. 5 times 1/5, we know on a multiplicative inverse, this goes to 1. So we really end up with 1x or just x equals 15 times 1/5. 15 times 1 is 15 over our 5. And remember what I said before, 15/5 would be the same as saying 15 divided by 5. Well, what is 15 divided by 5? It's 3. We now have solved a two-step equation using the additive inverse and the multiplicative inverse. Remember I said we always do additive inverse first and then multiplicative inverse? Well, this is true, but sometimes there's an order of operations we have to follow. And sometimes the multiplicative inverse comes first, then an additive inverse, and then the final multiplicative inverse. This might sound confusing, but let me show you an example of what I'm talking about. Say we have x plus 6 divided by 3 equals 8. All right, this might seem a little bit more difficult, but it really isn't. Because if we look at this on top right here really is just a number. So what do we have? We have a multiplicative inverse first. We need to get rid of this 3, or we can view this as, remember that this 3 is just like if we put a 1 out in front of this, this is 1/3 times x plus 6, which would equal 8. It's just a different way of looking at things to be able to determine what we have to do to solve this equation. And I'm going to show you this a couple different ways, but this is the way I want you to look at it first. So if we were going to do this, right now we see a multiplicative inverse we have to do first. We have to get rid of this 1/3 outside of the parentheses before we can work on what's inside the parentheses. Well, the multiplicative inverse of 1/3 is 3. Whatever we do to this side of the equal sign, we have to do to this side. So we multiply this by 3. We know now that 3 times 1/3 is really 1, so we really end up with just x plus 6. I'm removing the parentheses because we really don't need them anymore. Equals 8 times 3, which is 24. Now we're going to do the additive inverse. Boy, this is backwards of what I just showed you. But what is the difference here? The difference is that we actually had a multiplicative inverse first, and then we solved what was ever in the parentheses. So solve what's outside of the parentheses first, and then solve what's inside the parentheses last. So at this point, we can do a minus 6 here. We know that's the additive inverse, and a minus 6 here. Put a line underneath it. This is x equals 24 minus 6 is 18. And we've just solved the equation. Now that may seem a little bit difficult, but let me show you another way that I would solve this equation. Let's put x plus 6 over 3 equals 8. Now, I'm hoping I don't confuse you on this because this is really the way I look at it. I'm looking at this equation first, and I know that I have to get rid of this 3 first. I can't do anything with a 6 until I get rid of this 3. All right? So I can actually, I know I'm dividing by 3 here, so if I'm dividing by 3, I'm going to multiply by 3. Whatever I do on one side, I do to the other. Now I know 3 times this, or 3 divided by 3, this all goes to 1. And if that's 1, then I'm left with x plus 6 equals 24. I've just quickly gone to the step of additive inverse without having to deal with pulling that 1/3 out and putting parentheses around the x plus 6. I know that I'm dividing by 3 here, so I have to multiply by 3. In this case, this is what works. And then I can subtract out my 6's, and again, I come up with a minus 6 on here would be 18. Let's do one more example. And this one's going to be a little bit more difficult because we're going to deal with negative signs in this example. Let's take a look at x over a negative 8 minus 5 equals a minus 2. Boy, that's a lot of negatives to deal with, but we can do it. It's not a problem. So the first thing we have to do is we have to take care of our additive inverse, right? We can do this in this case because this 5 is kind of left by itself, this negative 5. So we're going to take care of our additive inverse first. Whatever we do on one side of the equal sign, we do on the other. Put our line there. We bring down our x over a negative 8. This goes to 0, so we leave it, equals negative 5, or negative 2 plus 5 is a plus 3. Okay, we've gotten that far. Now we take a look at this negative 8 in the bottom. Remember before, that last example, when we had the 3 in the bottom, all I did was multiply by, it's really multiple of inverse, right? Because this negative 8 is really negative 1/8, or in the case of the 3 was a negative 1/3, or a negative third. So I'm going to just multiply by its multiplicative inverse, which in this case would be a negative 8. This is 1/8, negative 1/8, and we're going to multiply by negative 8. What we do on one side, we have to do on the other. This cancels out. We're left with an x here. This equals 3 times a negative 8, which is a negative 24.